In section 7.5, we're going to talk about solving trigonometric equations. A lot of what we're going to do is going to use concepts that we've studied in previous sections. So things you need to be able to do. You need to factor quadratics or greatest common factor. You need to be able to substitute, like substituting one trig expression for another using our reciprocal quotient and Pythagorean identities. You need to be able to use the zero product property. That's the one where if you have two things being multiplied, or three things being multiplied, or four things being multiplied, and they're equal to 0, then you set each equal to 0. You need to be able to solve inverse trig equations. Those are the ones where you're going to use the inverse functions on your calculator. And you need to be able to also work in radians. Well, although what we'll probably do is we'll convert everything to degrees and then transfer it back to radians at the end of the problem. So when we studied inverse trig functions, we talked about something called principal values. In your calculator, if you do an inverse sine or an inverse tangent, the answer you get will always be in either quadrant 1 or quadrant 4, except if the answer is in quadrant 4, instead of giving you an answer between 270 and 360, it's going to give you an answer between 0 and -90. Inverse cosines will always give you an answer in either quadrant 1 or 2. So it's going to give you an answer somewhere between 0 and 180 degrees. Let's talk about solving trig equations. So we ran across a problem like example 1 when we were in section 7.2. It says solve 2 sine squared x plus sine x minus 1 equals 0 for principal values of x. That means whatever your calculator gives you, and express it in degrees. So make sure your calculator is in degree mode before you do this problem. What I want you to notice is that this is just a quadratic equation. It's really just the quadratic equation 2x squared plus x minus 1 equals 0. And in order to solve this, we're going to write this in factored form. Now, you can go and factor this any way that you want. You can go use the x method if you learned that. You can do factor by grouping if that's how you learned it. I'm particularly fond of this third method, which is graphing and finding the solutions, because I don't really need to factor it, then I can just solve for x. So what I would do is in my calculator, I'm going to graph 2x squared plus x minus 1. So this is the graph of just 2x squared plus x minus 1. And what I want you to notice is that it hits the x-axis at -1, so one of the solutions is -1. And the other one looks like it's halfway between 0 and 1, so maybe it's at 1/2. If you make y2 equal to 0, so y1 is 2x squared plus x minus 1, and y2 is 0, and then you use the intersect function to find where the graph intersects the x-axis, it will tell you that it's 0.5. All right, so now I'm going to go back here. My solutions are -1 and 1/2. Except I'm not really solving this quadratic. I'm really solving a quadratic that has a trig function in it. All I have to do to account for it is stick the little sign in front. So I'm really solving sine x equals -1 and sine x equals 1/2. So to solve the first equation, we're going to do the inverse sine of -1. And as long as your calculator is in degree mode, make sure you check it, the calculator's going to spit out -90 degrees. And then in the second equation, when I do the inverse sine of 1/2, the calculator is going to spit out 30 degrees. So those are the principal values in degrees. All right, let's go do it again. In example 2, I want to sine squared x minus sine x plus 1 is equal to cosine squared x. But this time I want to solve it for all values between 0 and 2 pi. Now, for the sake of our problem, let's find all the answers between 0 and 360, and then just change the answers back to radians at the end of the problem. So the first thing I want you to notice is I have sines and cosines. I don't want that. So what am I going to do to get one type of trig function? Well, if you think back to section 7.1, we had determined that cosine squared x was the same as 1 minus sine squared x. So I'm going to start by converting that. So sine squared x minus sine x plus 1 is going to equal 1 minus sine squared x. This is a quadratic equation. How do I know it's quadratic? Quadratic means that one of the terms is squared, which it is. So in order to solve this problem, we're going to get the equation equal to 0. So I'm going to add sine squared x to both sides. That's going to give me 2 sine squared x. And then I'm going to subtract 1 from both sides, and look, it makes both of those go away. So I'm really left with 2 sine squared x minus sine x equals 0. Well, this is much easier to factor because it's not a trinomial. Instead, it's better to just take out the greatest common factor. Well, they both have a sine. So if I take out a sine x, I'm left with 2 sine x minus 1. Remember, factor means divide, and sine x divided by sine x is not 0, it's 1. So now I'm going to go use the zero product property. So I'm going to set sine x equal to 0 and solve that equation. And I'm going to set 2 sine x minus 1 equal to 0 and solve that equation. Well, if you solve that using algebra, you have to add the 1 and divide by 2, so I'm really solving sine x is equal to 1/2. Now remember I said I'm solving between 0 and 2 pi. That means I'm solving for an entire circle. So when you do the inverse sine of 0, you're going to find out that the answer is 0. But it turns out there's another location where the sine of x is equal to 0, and that's at 180 degrees. Think about the unit circle. Matter of fact, you may want to pull out your unit circle to help you with these problems. Now, sine x is equal to 1/2. Well, we just did that problem up here, and we know that at least one of the answers is 30 degrees. The question is, what's the other answer? In what other quadrant are sines positive other than quadrant 1? Well, they're also positive in quadrant 2. So there must be an angle in quadrant 2 whose reference angle is 30 degrees. Well, that's going to be 150. Now, the problem is that the original problem was in radians. So we're going to have to change this back to radians. All right, so in radians, 0 is 0 and 180 is pi. 30 degrees is pi over 6, and 150 is 5 pi over 6. You can either use your unit circle or remember that you change degrees back to radians by multiplying by 180 or pi over 180 and then reducing the fraction. All right, let's go do one more problem. Let's go look at 4 cosine x sine x minus 2 sine x minus 2 radical 3 cosine x plus square root of 3 is equal to 0. You may be looking at this problem going, oh, I can't substitute anything. I've got 2 different trig functions. I've got no squares. What am I going to do? Well, I want you to notice that there are 4 terms. I know, you're probably looking at that going, well, that's 2 terms. No, it's 1. A term in a polynomial was any number, letter, or combination of numbers and letters. And they're separated by plus and minus signs. So when you have 4 terms, we like to use something called factor by grouping. That's where you take the first 2 terms and group them, and then you take the next 2 terms and group them, and now we're going to factor out any greatest common factor. So from the first group, I want you to notice that they have in common a 2 and a sine x. So I'm going to factor out 2 sine x, and I'm left with 2 cosine x minus 1. And in the second group, I want you to notice the only thing they share in common is a square root of 3, but I don't like negatives, so because of that negative, we're going to factor out negative square root of 3. Remember, negative means divide. So you're going to be left with positive 2 cosine x minus 1. Factor by grouping only works if when you're done factoring the groups, these are the same. We're doing the distributive property backward. So one of my factors is going to be 2 sine x minus the square root of 3. And the other factor is going to be 2 cosine x minus 1. And now I'm ready for the zero product property. So I'm going to set the first factor equal to 0. And then I'm going to set the second factor equal to 0. And we'll talk about what it means for all real values of x in a moment. And it didn't distinguish between degrees or radians. So I would just do this in degrees because I think it'll be easier. So think about this problem algebraically. You would add square root of 3 and divide by 2. So we're going to do the inverse sine of square root of 3 over 2. Let's get rid of that. And in my calculator, it'll spit out 60 degrees. Except there's another location where the sine is going to be square root of 3 over 2, and it's going to be in quadrant 2. In quadrant 2, the angle will have a reference angle of 60 degrees. All you have to do to account for all real values of x is add a plus 360n to both of them. I just wrote it once. So it's 60 plus 360n and 120 plus 360n. And the reason is because we know that the period of sine and cosine is 2 pi. 2 pi is the same as 360 degrees. Now, second equation. First I'm going to add 1 divide by 2, and now we're going to do an inverse cosine of 1/2, and you're going to find out the answer's 60 degrees. But the other quadrant, where cosines are positive, is quadrant 4. So what angle in quadrant 4 will also have a reference angle of 60 degrees? Well, it's 300. So my answers are 60 plus 360n and 300 plus 360n. If you wanted to change these to be in terms of radians, the only difference is that they would be pi over 3 plus 2 pi n, and 2 pi over 3 plus 2 pi n, and this is also pi over 3 plus 2 pi n, and then 300 is 5 pi over 3 plus 2 pi n. But I'll be very specific and tell you what units of measurement you should be in. Should you be in degrees or radians? And that is section 7.5 on solving trigonometric equations.